Hey guys, welcome back to Evamiro Academy, and in this video, I'm going to be teaching you about how a rocket gets to space. How does a rocket get out of the atmosphere? How does it get into orbit or to another celestial body like the moon? Can't be rocket science, can it? So in this video, I'm going to be answering all of these questions. Let's get started. First of all, let's just talk about the goal of a rocket in the first place. Its goal is to get to its destination, let's say the moon for example, using as least fuel as possible. Fuel is expensive and heavy, so having too much of it could outweigh the power of the thrusters, and the rocket wouldn't even be able to get off the launch pad without toppling over. And getting to the moon does not mean just flying directly towards it. Although it would eventually work, it's not at all fuel efficient. The most fuel efficient way to get to the moon is to orbit the Earth, and then extend that orbit in a way that intersects the moon's trajectory. This will cause a gravitational encounter with the moon, and then you can slow down a bunch and land on the surface. I think this will be much easier to explain if I just show you. Okay, so here I'm using a spaceflight simulator that mimics real-life physics and maneuvers. So we're here on the launch pad, and you'll see we have these two boosters on the side of the rocket. Their purpose is to simply get us out of the atmosphere, so they'll be ditched as soon as they run out of fuel for our main engines to do the rest of the work. So let's go ahead and launch. And you'll also notice at the bottom of the screen something that's called an attitude indicator. This basically tells us which angle the spacecraft is facing and where our forward velocity lies. You'll see I'm tilting the spacecraft slightly to the right, and this is so we can get a good forward momentum into a circular orbit. Now you see we're ejecting those two boosters as they run out of fuel, and you see when we look at the map, we have a parabolic trajectory. The peak of our orbit is called the apoapsis, and it is most efficient to burn at these extreme points of an orbit rather than anywhere else. So we burn the rest of this engine's fuel to get the apoapsis as high as possible to prepare for our next maneuver. Once the engine runs out, I'm cutting the throttle and just waiting until we reach the apoapsis. In the meantime, you'll notice I begin plotting a good trajectory for our orbit around the Earth by increasing our forward momentum. This type of motion is known as a prograde burn. So when it gets around T-minus 15 seconds before we reach the apoapsis, I burn at full throttle prograde until we get a nice circular orbit around the Earth. Then I cut the throttle. Now you'll notice a new marker popping up called the periapsis. Unlike the apoapsis, which is actually the farthest away our orbit is from the Earth, the periapsis is actually the closest point in our orbit to Earth. So now that we're in an orbit, the next goal is to get to the moon, and the only way to do that is to intersect our orbit with that of the moon's orbit and encounter its gravitational pull. So if we burn prograde at any point in our orbit, remember burning prograde means increasing forward momentum, we can extend our orbit far enough that it intersects the moon's orbit. And we can't just go to where the moon is right now, because by the time we get there, the moon will have already gone past us, so we have to make sure that the moon will be there at the same time we are there. So after fiddling around a bit, I get a good close encounter with the moon, and execute the burn for around 1 minute or so, and then cut the throttle. Now this orbit is pretty big, so to actually get to the other end of the orbit, it would probably take a few days to a week to get there. But since this is a simulation, luckily I can time warp through all that. Once we get there, we can burn retrograde at the peak of our orbit. Burning retrograde means that we're decreasing our forward momentum and slowing down, the polar opposite of prograde. So I burn retrograde for around 20 seconds until we get an orbit around the moon, and then burn a tiny amount on the other side of the orbit until we get a crash course trajectory onto the moon. Next is the last but most definitely not least part of this journey, landing. Now we don't want to be landing too fast or else we'll blow up into smithereens. So just as we're over our landing site, I burn retrograde at full throttle, effectively killing all our speed quite quickly because the moon's gravity is so low. Now we're coasting at a mere 5 meters per second. And touchdown! Whoops, looks like we've fallen over. But you know, like they say, any landing you can walk away from is a good landing. So I hope in this video I taught you a lot about spacecraft and orbital maneuvers in a fun and interesting way. Make sure to subscribe to Evamiro Academy for more awesome content like this. If you want to see more content from me, then you can go over to my personal channel. It'll be linked in the description down below. Thank you so much for watching, and we'll see you next time. Bye!